Hi students, today we are going to see block diagram realization of discrete time systems direct form 1. This is Benila from RM Engineering College. So differential equations of discrete time systems can be given by y of n is equal to minus summation k equal to 1 to n a suffix k y of n minus k plus summation k equal to 0 to m b suffix k x of n minus k. So if we expand the summation by substituting the value of k as 1 to n for this term and k as 0 to m for this term, we'll be able to get this one. So finding the z transformation of this one, so your y of n z transformation is y of z, then y of n minus 1 z transformation is z power minus 1 y of z, n minus 2. So x z power minus 2 y of z, it goes on. So just move all your y of z one side, all your x of z another side to get the transfer function h of z. So after taking that y of z commonly out and x of z commonly out, we'll be able to get so b0 plus b1 z inverse plus b2 z power minus 2, it goes on and divided by 1 plus a suffix 1 z inverse plus it goes on a suffix n z power minus n. So this is the transfer function of the DT systems here. Okay, so here your m is called as number of zeros and n is called as number of poles. So there are four different structures in DT systems, that is direct form 1, direct form 2, cascade and parallel. So in this session we are going to see direct form 1. So the basics needed for the structures are adder. So the adder will be represented by this x1 of n and x2 of n be the two input signals. Your y of n will be x1 of n plus x2 of n. The next basic structure is multiplier. So x of n is multiplied by the value a. So a into x of n. And the third one is your delay element. X of n is passed through the delay element z inverse will be obtained, will give x of n minus 1. So direct form one structure. So we are going to consider the basic difference equations here. So in this one we are going to take two equations, that is all the input and input delayed version will be taken as equated by w of n, that is your temporary function, and then I will be replacing into the main equation. So y of n is equal to minus a1, that is delayed version of your output, plus your w of n. This input and delayed version of input is replaced by w of n. So now I got two equations, w of n is equal to something and equation number 2, y of n is equal to something. So find the z transformation of these two equations and then draw the structure. We will be getting your direct form 1. So here W of take your Z transformation. So y of Z is equal to minus A1. Y of n minus 1 can be written as Z inverse y of Z. It goes on here, right? And for W of Z, I'll be taking the Z transformation. So the B naught x of Z plus B1 Z inverse x of Z, it goes on. So now for these two equations, we are going to draw the structure. So that will give you the direct form 1. So first equation is W of Z is equal to something. So this is nothing but B naught into x of Z plus B1 Z inverse x of Z, it goes on. So the structure is W of Z. So this is going to be your W of Z. So B naught into x of Z, B1 Z inverse x of Z. So B1 Z inverse x of Z, B2 Z power minus 2 x of Z, it goes on. And the second equation is y of z is equal to minus a1 z inverse y of z minus a2 z inverse y of 2. So for this one, so here minus a1 z inverse y of n minus a2 z inverse y of n, z power minus 2 y of z, it goes on, plus your w of z. So here this input as well as your output section have separate delays here. So direct form 1 structure has separate delays for both your input and output. So total number of multiplications is m plus n plus 1 and addition is m plus n and memory location is m plus n plus 1. So this is a basic gate questions here. So we can solve some problems here. Realize the second order digital filter y of n is equal to 2r cos omega y of n minus 1 minus r square y of n minus 2 plus x of n minus or cos omega x of n minus 1 in direct form 1. So in direct form 1, we have to get two equations. W of n is equal to something and y of n is equal to something. And then you have to draw the structure. So this is the basics. So I'll be splitting this equation into two parts. So this is going to be input and input delayed version, and this is going to be the output delayed version. So I equate this input and input delayed versions to W of n. So then I'll be replacing it in the main equation here. Right, so W of n, this x of n minus r cos omega x of n minus 1 as W of n, and replace it in the main equation as this one. So now I got two equations, W of n is equal to something and Y of n is equal to something. So find the Z transformation of this one. So Y of Z, X of Z minus R cos omega, Z inverse X of Z. And then here, this is the Y of n is Y of Z, 2R cos omega, Y of n minus 1 is Z inverse Y of Z minus R square, Z power minus 2 Y of Z plus W of Z. So for these two equations, I am going to draw the diagram here. So W of Z is equal to X of Z minus R cos omega, Z inverse X of Z. So I'll be getting this equation X of Z, W of Z and then Y of Z. So this is the basic here, right? So now you have your W of Z here. So W of Z is equal to X of Z. So this is X of Z and then Z inverse. So only one delay you have. So I'll be taking this delay from your X of Z because Z inverse into X of Z. So I'll be taking the Z inverse from your X of Z. So X of Z coefficient is going to be 1 and then Z inverse coefficient is minus R cos omega. Then the second equation y of z is equal to, right? So 2r cos omega z inverse y of z minus r square z power minus 2 y of z. So here you have two delays. So I'll be getting two delays here. Okay. So here first is plus w of z. So already here you have your w of z. So z inverse y of z. Why I am taking it from z in y of z now? So here z inverse y of z. So z inverse is taken from y of z. So the first value is 2r cos omega. So 2r cos omega for z power minus 2 it is minus r square. So this is your minus r square and this is your direct form 1 structure. Right. So in shortcut method you have to get it now. So to get your h of z. Right. So this side will be given by numerator. So numerator will give you this side. Right. And this side will be given by the denominator, right? So then what happens here? Numerator is z inverse you have. So only one delay, right? So first value will be 1 and second value will be minus r cos omega. You can drop it straight away. This side is your denominator. Here you have z power minus 2. So you have two delays, right? So always this value will be 1 irrespective of anything, right? Then it is you have your sign change. So for z inverse the value is minus 2r cos omega. So you have your sign change. So it becomes 2r cos omega. And for z power minus 2 plus r square. So it becomes minus r square. So this is the shortcut method to draw the structure directly. So we'll go for one more problem here. So here also they have given your y of n, right? They ask you to get it in direct form 1. So the procedure is we have to get two equation. W of z is equal to something. Second equation is y of z is equal to something. So in this equation, input and input delayed version will be equated to W of n. So then I'll be replacing this in the main equation. So W of z is equal to x of z plus 0.4 z inverse x of z. So here if I replace it by main equation here, I'll be getting this as a 0.5 z inverse y of z minus 0.25 z power minus 2 y of z plus x of z. So draw the equation, draw the structures for the first equation. W of z is equal to x of z plus 0.4 z inverse x of z. So here only one delay element here. So I'll be getting one delay element. So W of z is equal to x of z. So coefficient is 1 and then z inverse coefficient is 0.4. So the second equation is y of z is equal to 0.5 z inverse y of z minus 0.25 z power minus 2 y of z. So two delays here, right? So z inverse coefficient is 0.5, z power minus 2 coefficient is minus 2.5. So here in the shortcut method you can take it. So numerator will be this side, denominator will be this side. So 1 and point 0.4, here it is sign change. Z versus minus 0.5, so it becomes plus 0.5. Z power minus 2 is 0.25, so it becomes minus 0.2.